Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad, 9th grade, 2014, problem number 1. We wish to find all irrational numbers x such that x squared plus x and x cubed plus 2x squared are both integers. So here are my hints for this problem. First, write that x squared plus x is k, x cubed plus 2x squared is L for some integers k and L, and from the first equation you should be able to derive x squared equals k minus x and use this in the second equation to find some relationship between k and L. And the problem should be straightforward from there. So give this problem a try. Alright, so as I suggested, let's say let k be equal x squared plus x and L x cubed plus 2x squared, where k and L are some integers. Alright, from the first equation we derive that x squared equals k minus x. From the first equation. Now let's tackle the second equation. We have x cubed plus 2x squared equals L. But now, on the left hand side, x cubed can be written as x times x squared, but x squared can be replaced by k minus x. Likewise, here we can also place k minus x equals L. We have kx minus x squared plus 2k minus 2x equals L. And once again, we can leave kx as it is, and instead of x squared, I will write k minus x plus 2k minus 2x equals L. So after simplifications, on the left-hand side, we have kx plus x minus 2x, and let's put everything else on the right-hand side. We will have k minus 2k plus L. So we have the following: k minus 1 times x equals, L minus k. Alright, but now remember that x is irrational, so the only possibility for this equation to be true in integers is that both sides must be equal to 0. Let's write it. Since k and L are integers and x is irrational, it must be the case that k minus 1, k equals 1, and k equals L. Alright, so now we know the value of k, so we can now go back to our first equation and we can just solve it because k equals 1. So x squared plus x equals 1, x squared plus x minus 1 equals 0. We can compute the quadratic discriminant. It's 1 squared plus 4, 5. So we have two solutions. X is either minus 1 minus square root of 5 over 2, or x is minus 1 plus square root of 5 over 2. So these two numbers satisfy our first equation, and the second equation is automatically satisfied as well. We have exactly two solutions. Well, you know what? We can verify the second solution as well. There is no need to do it by. Let's do it. So x cubed plus 2x squared. It should be 1. Notice that it's x squared times x plus 2. We know that x squared from this equation, x squared is 1 minus x. It's 1 minus x, x plus 2. We have x plus 2 minus x squared minus 2x. So it's minus x squared minus x plus 2. And once again, we know that these two numbers satisfy x squared plus x equals 1. So it's minus 1 plus 2. It's 1. It's an integer. So our solutions are exactly these two numbers. Our solutions are exactly these two numbers. They are connected to the golden ratio, by the way, because this third number is minus the golden number. The second one is the inverse of golden number. And that's it. So thank you very much for watching. I will see you next time. Goodbye.